Let us solve a problem involving frictional force. So in this problem, a block of weight 200 Newton is placed on a rough horizontal floor. A block of weight 200 Newton is placed over a rough horizontal plane like this. Its weight is 200 Newton. Then if mu equal to 0.25, that is the coefficient of friction mu equal to 0.25, find the pull P required to move the block if P is inclined upwards at 30 degree with the horizontal. That is, we need to pull the block in the horizontal direction by applying an inclined force P at an angle of 30 degree with the horizontal. We need to find the magnitude of P. So this force P is at an angle of 30 degree with the horizontal. Okay. So we need to find the force P just to move the block. That means limiting friction is coming in between the contact surfaces. So we know the equation for limiting friction F is equal to mu into Rn, where Rn is the normal reaction between the contact surface in the vertical direction, and F is the limiting friction, mu is the coefficient of friction. Now here mu is given, Rn can be found out using equilibrium equation in the vertical direction, and we can find out the value of P. So we know in this case there is no motion in the vertical direction, so we can apply the equation sigma V equal to 0. Now to apply this condition, we have to draw the free body diagram first. Let this be the body. This is the weight acting vertically downwards. Then this is the normal reaction acting in upward direction, vertically upward direction. Then a force of P at an angle of 30 degree with the horizontal. Then the limiting friction force F equal to mu into Rn. So these are the forces acting on the body. So this will be the free body diagram, and if we apply sigma V equal to 0, that is the algebraic sum of forces acting in the vertical direction equal to 0. So what are the forces acting in the vertical direction? So there will be this component, that is 200 Newton. It is acting in the vertical downward direction, Rn in the upward direction, and there will be a component of P in the vertical direction. And that component will be like this. This is 30. So this will be the vertical component of P, and hence it will be P sine 30. Okay, it will be P sine 30. So these are the forces acting on the body. So if you draw the free body diagram with the components of the forces also, it will be like this. The weight 200 at this point, this force P sine 30, P cos 30, Rn, I'll draw the force of friction here, F equal to mu into Rn. So these are the forces, or after resolving the force P into two mutually perpendicular components. Okay, now we will apply sigma V equal to 0. So sigma V equal to 0 gives the Rn is upwards, it is taken as positive, plus P sine 30 is also taken as positive, minus 200 equal to 0. Rn plus P sine 30 minus 200 equal to 0. Then we can say, under the action of this force P and the limiting friction, this body is in equilibrium, or the body is just about to move. Okay, so that means this, as the body is in equilibrium in the horizontal direction, the net force or the algebraic sum of forces in the horizontal direction can also be assumed to be equal to 0. That means, like we have applied the sigma V equal to 0, sigma H also equal to 0. That is, what are the forces in the horizontal direction? Two components are there, F and P cos 30. So P cos 30 minus mu into Rn equal to 0. How we assumed this thing? It is because under the action of the frictional force and the horizontal component of P, this body is in equilibrium at this moment. In the next moment it may move, because this force will overcome the force of friction or limiting friction. So this is the second equation. So we have two equations in Rn and P. Rn and P. So solving these two, we can find out the value of the magnitude of P. So from 1, we will get Rn equal to 200 minus P sin 30. So we will substitute this value here, that is in second equation. Let this be the second equation, this be the first equation. Therefore equation 2 will give P cos 30 minus 0.25 into 200 minus P sin 30 equal to 0 from equation 2. When we substitute the values of this cos 30, sin 30 and mu, we will get P equal to, this will give P equal to 50.45 Newton. That will be the answer.